This is the analysis of Zipf's law. What is Zipf's law? Zipf's law was proposed by American linguist George Kingsley Zipf in the 1930s. It describes a relationship between the frequency and rank of different words in a data set. Multiplying the rank times frequency should be similar for different words in the corpus. To put it simply, the most frequent item occurs around twice as much as the second most occurring item and 3 times as much as the third most occurring item. Some background. Zipf analyzed very large corpuses of text from several languages, and he found this pattern in all of them. He originally intended this law to only be applied to linguistics, but he found it in other fields. His primary focus being the discovery that rank versus distribution of financial incomes in a unified nation does reflect this law to a large degree. This law was found to be applicable in other types of data sets, like the rank of musical notes in a composed piece, corporation sizes, income rankings, and many more. What makes a corpus a good fit? We need a metric to decide how good of a fit a corpus is for Zipf's law. There are a few mathematical ways to do this. Plotting the log of the frequency on the y-axis and the log of the rank on the x-axis can show us if it's a good fit. Mean deviation is a measure of how far observed frequencies deviate from expected frequencies according to Zipf's law. This picture shows an example of something that fits Zipf's law well. We decided to plot the log of the frequency and the log of the rank on a graph. In the case of the good fit, the plot should be linear and it should have a slope that's around -1. If it's a bad fit, it won't be linear and there'll be many areas where there's a lot of deviation. Only if deviations present themselves, we will determine that it isn't a good fit for Zipf's law. Deviations at the beginning and the end are more acceptable than deviations in the middle. We decided to analyze Moby Dick, mainly because it's a very large size. We analyzed a page, a chapter, and the entire book for rank frequency distribution. We plotted the resulting log of the frequency against the log of the rank, and we're comparing the chart for each, for the page, the chapter, and the entire book. Analysis of page 1. There's significant linear deviations from linear was found throughout. The discrepancies occurred much more often at the beginning and the end of it. It makes sense that there's fewer overall words. There'll be larger visible jumps as words go from occurring many times to very few. We can see there's like a step each time it goes to a different word, so it doesn't follow Zipf's law very well at all. Analysis of a chapter. It's a slight improvement from a page, but it still doesn't follow Zipf's law very well. There's a ton of inconsistency at the end, especially. And then the middle of it kind of fits Zipf's law, but overall it's still not a very good fit. And then this is the analysis of the entire book. This is a huge improvement compared to just the page and the chapter. The only areas of inconsistency were with the highest and the lowest ranked words. The problem at the end is much smaller than for the other graphs, so overall we believe it's a pretty good fit for Zipf's law. Comparing our 3 runs, we can easily see that as we increase the size of the corpus, it fits Zipf's law better. They became more linear and there was less deviation as we increased the corpus, so it was a much better fit for Zipf's law. Conclusions about Zipf's law. We can definitely say that Zipf's law works much better for larger corpora. There's a direct improvement in linearity and frequency as the size of the corpus increases. The pattern makes a lot of sense, as there'll be generally fewer large relative jumps in frequency as the corpus size increases and number of unique words. These large jumps will still occur around where words are only occurring 1 or 2 times. There's many sources that say that those should be excluded, the words that only occur like once or twice. Since our final run represents a law strongly in all areas but the beginning and the end, we believe that the law does fit for our analysis of Moby Dick.